Now let's see how to write code for LCD in assembly language. Again, open the Kyle software. Go to project, new Mu Vision project. I want to save it to LCD project. Then ASM assembly file. Give name to your project. I am giving LCD. Then select the microcontroller that you want to use. Then click on new file. Save this file with extension .asm or .s, both will work. Then add that file to your project directory. Now you are ready to write the assembly language code. So here is the code for displaying character on LCD screen using assembly language. You will start assembly language code with the origin assembly language directive. 00H is the address from where I want to write this code to the ROM locations. Let's assume that the D0 to D7, these are the data pin of LCD, are connected to port 1.0 to 1.7 pin of 805 microcontroller. Similarly, RS, RW, E, these are the control pins of LCD connected to port 2.0, 2.1 and 2.2 of microcontroller. Here, EQU is like a hash defined in C language. That simply means in place of port 2.0, I want to use word RS. If you want more information on EQU, you can go to help. Right here EQU, and you will get the complete information about EQU assembler statement. EQU is simply you consider it as an equate or simply giving the another name to the particular port pins. Now, to send data, we have subroutine called send command, and to send command we have subroutine send command, and to send data we have subroutine send data. To send command, first you have to load the particular command to the port pins. So the instruction is move p1 hash 38h. That means 38h, this hex data get loaded to port P1. So we are simply sending 38h data to port P1. Then a call, send command. A call is like a call function is like a function calling C language. So a call, send command. This subroutine is nothing but clear RW since we want to write data, clear RS since this particular data we want to write to command code register. So command subroutine will write data to command code register by selecting RS pin 0. Then the data is available at this condition. The data is available on port pin. To latch the data present on port pin inside the LCD, you have to use this condition. First set enable pin, a call delay, call some delay and then clear that pin. So this is the subroutine for send command. To come out of the subroutine, you have to use instruction RET, return from subroutine. So always, first you have to load the data to port pins, then you have to use send command. So when these two instructions will get executed, that means the 38H, this command is now get returned to the command code register of LCD. Similarly is true for other instructions. 0E for display on cursor blink, 01 is for clear display screen. Now let's see how to send data. To send data, first you have to load the value to the port pin and you have to call the send command. To send a data, you have to load the data value to port P1 and then you have to call to send data function. Send data is same that of your send command. There is only one difference is, and that difference is nothing but the RS pin. Here we clear RS pin, that means the command code register gets selected. Here we set the RS pin, that means the data register of LCD get selected. So RW we want to write, where we want to write? We want to write to the data register, then the data is present on data pins. To latch that data inside the LCD, you have to use this condition: set B enable, then call some delay, then clear enable. To return from subroutine, RET. So now you come back here. So using these two instructions, you can send data to data register of LCD. Similarly is true for other characters. Here we have written E in single quote. That means we want to transmit the ASCII value of E. Okay. Then we have delay function. So delay subroutine is used to generate some delay. And to come back from this delay subroutine, RET instruction is there. So this one is an inner loop and this one is outer loop. So here one form, we can say the one for loop, and here two, it form the outer for loop. So this two loop will generate a delay. So your flow is like this. First you send initialization command, then send data to LCD that you want to display. Move P1 80H means the 80 here is the command that will get sent to LCD using send command. This will force cursor to first line, and hence after this command, whatever you will write, it will get displayed on first line of LCD. C0, this command is to force cursor to second line. Means after this command, if you send some data, that will get displayed on second line. We want this embedded lab word to display continuously on LCD, so I will write it in a while one loop. To create while one or continuous loop in assembly language, the instruction is jump, or you can use short jump. So short jump, this instruction is there to create a continuous loop. Now here is pointing to this instruction. So this particular line of code will get executed infinite times. Okay, now let's debug the code. Before debug the code, select target options, make a frequency as 11.0592 megahertz, output create hex file. Okay, then do transmit bit and reload. We got 0 errors. That means we can proceed for debugging process. Okay, since you are sending data to port 2 and port 1, go to peripherals, take port 1 and port 2. So when I run this code continuously, you can see the changes on port, but we are unable to visualize the character display on LCD screen. For that purpose, you can use the Proteus software. To create Proteus project, go to File, New Project, then give project name to, it's in my case LCD. I want to save this project on ASM. Proteus project. Okay, click next, finish. Click on ISIS. Click P. Then choose the microcontroller that you want to use. We required one more component, that's nothing but LCD. Make a connections. RS is connected to port 2.0, RW to port 2.1, enable to 2.2, D0 to port 1.0, D1 to 1.1, D2 to 1.2, D3 to 1.3, D4 to 1.4, D5 to 1.5, D6 to 1.6 and D7 to 1.7. Double click on microcontroller, make a frequency as 11.0592 megahertz. Select the hex file and make sure that you have selected the correct hex file. Yes. Okay. Run the code. Now here is the output.